Hello, all. Good evening. We'll wait for maybe a couple of more minutes so that more people join, and then we'll start.
Okay, ma'am.
Okay, ma'am.
Yeah. All right. Let's start then. I don't see anybody else joining. Um, okay. So today we have week 10 activity and practice, right?
Yes, ma'am.
Hmm. Okay. So uh, maybe what we can do is last session you would have revised all the topics from week 10. So today we can do the problems from week 10. Okay. So I'll share my screen and you can let me know what problems you are facing issues in and we can discuss those. Yeah, so maybe you can let me know what are questions you have. Okay, Mayank, you're saying you have doubt regarding gate exam. So this is not the session for gate exam. So maybe you can ask it on some other platform. So anyone, do you have any doubts from week 10? Any activity, practice? Graded we cannot discuss. So
Ma'am, in activity 10.5, first question I have a doubt.
question number 10 point, sorry, AQ 10.5.
Question 1.
Okay, let's see what is there in the question. Mayank, not really. I mean, in IIT JEE, those questions are different. The kind of questions that you get there is different. Maybe for more reference, you can check out the GATE exam that happened this year, and they will get to know the difference. Okay. AQ 10.5, question number 1 says, what is variance of a square x plus b square? Right?
Yes, ma'am.
The question is, what is variance of a square x plus b square? So here x is a random variable and your a and b are constant, right? And you know the properties of the variance, correct? So if a is a constant and b is a constant, a square and b square is also constant. And we know that variance of a constant time random variable is nothing but a square times variance of x, right? And now variance of ax is a square variance of x. And even if you add another constant to it, if you add some constant b to ax, still it remains a square times variance of x, right? This you would have known. Now look at this question. Here it's exact same thing what we have written over here. It just in place of a, I have a square, and in place of b, I have b square, right? So you will get a square ka square variance of x, which is a to the power 4 variance of x.
Okay, ma'am. Ma'am, in question number 3 also I have a doubt.
Okay. The same activity practice.
Yes, ma'am. Same activity.
Okay. Question number 3. This question number 3 says, it says the variance of the number of tickets sold in a day in an opera theater is 25. So just from this statement, okay, if for each ticket sold, let me write everything, all the information that is given. So variance of number of tickets sold in a day, number of tickets sold in a day is 25. Okay. If for each ticket sold, the profit obtained is 25 rupees. Um, Profit for each ticket sold is rupees 25, right? Now, what is the variance of, what is the variance of profit obtained in a day? Okay. This is what you have to find. This information is missing. Okay. So we can say that this is my random variable. I can define my random variable x as profit in a day. So how much profit would you get in one day? So what we're saying is that for each ticket sold, I am getting a profit of 25 rupees, right?
Yes, ma'am.
Yeah. Uh, okay. So this is more like, okay, maybe we can call this random variable as, or let's not call it anything. So I can call number of tickets sold in a day as a random variable x. So what will be the profit? Or profit obtained in a day, what it will be? So sum 25 times this x, right? Profit obtained in a day would be 25 times x. Do you agree? If you,
Ma'am, how 25x?
yeah, see, if you're selling, I'm saying number of tickets sold in a day. In one day, number of tickets that are sold is x, okay? Not x rupees, x. So number of tickets sold in a day is x, okay? Now for each ticket sold, I mean, uh, for one ticket, profit you're getting as 25. One ticket, profit is 25 rupees. So if you are selling X number of tickets in a day, what will be the profit? Rupees 25x,
Yes, ma'am.
right? So this is 25x is exactly what here it is asking. Profit obtained in a day. Because in one day you sold X ticket. And for each ticket you sold, you got a profit of 25. So total profit that you got in one day is 25x.
Yes, ma'am.
And now you have to find the variance of 25x. So again, this is, you just have to use the properties of variance. So 25x would be what? Can you tell me what this number would be? Just use variance of ax equal
625 to variance of
625
x.
variance of x.
625 times variance of x. And what is variance of x? Variance
25, ma'am.
25.
25. So multiplying this, you should get the answer, right? You got it?
Yes, ma'am.
Okay. I see some questions from week 9 in the chat. But let's see first if anybody has questions from week 10. If not, then we can move to week 9.
Ma'am, in 10.6, first question, last option I have read out.
10.6, first question. Standard deviation of a random variable has the same units as the units of a random variable. What do you think? What should be the answer? Is it correct? This is the option you have doubt, right? Standard deviation of a random variable has the same units as the units of a random variable.
Yes, ma'am.
What do you think? Is it right?
Ma'am, I not understand. Can you explain?
Okay. So when we say unit, what do you mean? What do you understand by unit, first of all? Can you tell me what did you understand by same unit? Or forget same unit. What did you understand by unit? Any idea? Okay. So, what unit is like, we'll talk about, like, let's say random variable is height of a person. Okay. So maybe we measure the height in either centimeter or meter or feet, right? Anything. So all these are unit, right? So I can collect my data. Sorry, I mean, here we're talking about random variable. So my random variable can have these units, right?
Yes, ma'am.
Hmm. So when you find the standard deviation, what is the formula for standard deviation? What's the standard deviation of a random variable? It is expected value of x minus mu whole square under root, right? So when you do expected value of x minus mu whole square, so even the units get squared up. So if it was like centimeter square, if it was centimeter, unit is in centimeter, it will be centimeter square, the unit. And if you take the square root, this is again centimeter, right?
Yes, ma'am.
So whatever form you collected the data as, if you collected the data in, let's say centimeter or meter, and when you found the standard deviation, again, it would take the same unit, right? So that is why it is correct. Is it okay?
Yes, ma'am.
Okay. Any other doubt you have?
Ma'am, same activity, third question, ma'am.
Okay.
I'm getting 4.2.
Okay. You have three random variable x, y, z, y equal to x, and x and z are independent. Okay. Question number 3. You have x, y, z, and y equal to x, y equal to x, X and Z are independent. What else is given? Variance of X, variance of Z is 2 and 7. It's 2, variance of Z is 7. Then what you have to find is, what is the standard deviation of X plus Y plus Z? So you have to find standard deviation of X plus Y plus Z. So to find the standard deviation of X plus Y plus Z, you need to know the variance of X plus Y plus Z, right? This is, you need to know, right? And you can take the square root of variance and you can get standard deviation. Now, the question is, can you can you write variance of X plus Y plus Z equal to variance of X plus variance of Y plus variance of Z? Can you write it?
Not my ma'am, because only two are independent. One is dependent.
Right. But again, you have variance of, Y is given as 2X. So now you can write 2X plus Z. And this is equal to variance of 3X plus Z, right? And it is given that X and Z are independent. So we are good. So now we can write this variance of 3X plus Z as variance of 3X plus variance of Z, right? And variance of 3X is 9 times variance of X plus variance of Z. And variance of X is 2. So you have 18 plus 7. So 18 plus 7 is 25, right? So we got the variance of X plus Y plus Z as 25. So what will be the standard deviation?
5.
Right. It is clear, right?
Yes, ma'am. I did individually, so I got the wrong answer.
Uh, what do you mean by individually?
The variance of X plus variance of Y plus variance of Z I took, and then I solved.
Yeah, but X and Y, X, Y, and Z are not independent, so you cannot
Yes, ma'am.
write it like that. Any other question?
Ma'am, can you explain the concept of many independent?
What can I explain?
Many independent.
Many independent.
Variance of a many independent.
Sorry, I'm not getting it. Variance of what independent you're talking about?
Ma'am, she wanted to say that where how like this variance of independent random variables when we have more than two.
Oh, okay. All right. So like in this case, you had 3 random variables, right? So, uh, uh, see, if it was expectation, if it was, let's say you had to find expected value of X plus Y plus Z. You don't need to know whether X, Y, and Z are independent or not. You can always write, this is always true. You can always write this as expected value of X plus expected value of Y plus expected value of Z. Okay? But in case of variance, this is not true. You can write variance of X plus Y plus Z equal to variance of X plus variance of Y plus variance of Z only if they are independent. Variance of Y plus variance of Z is a condition if X, Y, and Z are independent. If they're not independent, then you have to subtract the covariances. So I think you have not studied that, so I'm not going there. But this you should take care. That is why here we did not write variance of X plus variance of Y plus variance of Z. We used the information that was given to us, that Y is nothing but 2X. And that's how we got variance of 3X plus Z. And now we got 3X and Z, and I know the random variable X and Z are independent. So I can write them as separately.
Okay, ma'am.
Okay.
Ma'am, the summation of property of this expectation is universal, whether it's
Hmm.
whether they are
Independent or not.
independent.
Yeah. That's called the linearity property of expectation. Any other question?
Madam,
Ma'am,
10.3,
9.6,
second question.
sixth question.
Okay. I heard 9.6. What
Sixth question, ma'am.
9.6, sixth question. And what about the other question? Who was there? Which
10.3, third question.
10.3, third question. Okay. First, let me take 10.3 and then I will go to 9.6.
10.3, second question, ma'am. Second question.
10.3, second question. Okay. The expected value of 10 biased die. What you're talking about.
Yes, ma'am.
So you have 10 dice, okay? You have, let's say, I denote x1 as outcome of the first die, outcome of die 1, x2 as outcome of die 2, so on till x10 as outcome of die 10, right? Now, all these expectations are given to you. So you are given expected value of x1, you are given expected value of x2, so on till expected value of xn. Okay. Now the question is, what is the expected value of the sum of the outcomes of the 10 dice? Right? So if you have to talk about, so you need to find expected value of sum of outcomes of 10 dice, right? And now what is sum of outcomes of 10 dice? Outcome of die 1 is x1. Outcome of die 2 is x2. And so on till outcome of die 10 is xn. So if I want to talk about the sum of outcomes of 10 dice, I can write this as x1 plus x2, so on till x10, right? And all of these xi is a random variable. And I know that expectation follows the linearity property. So I can write this as expected value of x1 plus expected value of x2 plus up to expected value of x10. And all these expectations are already given to you. So you can just add it up and you should get the answer. Hope that is clear.
Okay.
All right, let's go to 9.6.
Ma'am, same activity, fourth question.
Okay, just hold on. I will take AQ 9.6 and then I will come. I will write it over here.
Okay, ma'am.
Fourth question, right? I will take it.
Yes, ma'am.
Okay, 9.6, question number 256, right? I see here 256.
Yes, ma'am.
Okay. So 9.6. Let's take me question number 5, 6 first. Okay, so what you have given is you have given the CDF of number of defective items in the shipment. So you have so in the shipment there are 10 items. Okay, so we can define my random variable x as number of defective items in the shipment of every 10 items. So its CDF is given to us. The PMF is not given, but the CDF is given, and this is 0. When x is 0, less than equal to 0, you have 0.41 or x lying between 0 and 1. You have 0.78 for x lying between 1 to 2. You have 0.91 for x lying between 2 to 3. And this 1 for x greater than equal to 3, right? So the question is, what is the probability that there are 3 defective items in the shipment of 10 items? So what you have to find is, what is the probability that number of defective items is 3, right? So this is CDF that is given to you. Now, can you find now the question is, can you find the PMF from here? Do you know how to convert a CDF to PMF?
Yes, ma'am.
You
You
know,
have to
okay.
subtract
Yeah, you have to subtract, right?
consecutive probabilities.
Now, okay. So this is x less than 0, you have 0. Okay. Now x between 0 to 1, you have 0.41. So if let's say this is my 1, 1, so this is 0.41. So between 0 to 1, you have the probability, the CDF 0.41. Between 1 to 2, you have 0.78. 2 to 3, you have 0.91. So 91 will be very close. And then x greater than equal to 3, you have 1. This is how the PMF will look like.
Yes, ma'am.
Right. Now, what is the probability that x equal to 1 or not x equal 1? So here your random variable, first tell me what is the range of x? What is the range of the random variable? Like what all values your random variable is taking?
0 to 10, maybe
0 to 10.
Ma'am, 0 to
0 to
3.
1.
0 to 1. I am asking
Ma'am, 0 to 3.
0 to 3. 0, 1, 2, 3. I didn't ask what is the range of the CDF. I asked what is the range of your random variable. So range of a random variable means like what all values your random variable is taking. And how did you define the random variable here? In this question, you define the random variable as number of defective items in the shipment. Okay. And using the CDF, we found that x can take the value 0, 1, 2, or 3. All right. Now, what is the probability that x equals 0? What is the probability that x equals 0?
Ma'am, 0.41.
0.41.
Okay. What is the probability that x equal 1?
0.7,
0.
78.
0.37.
Okay, some people are saying 0.78, some people are saying 0.37. Which one is correct? How many people are saying it is 0.78?
Yes, ma'am. Me.
Okay,
Me,
2 people are saying 0.78. How many are saying it is 0.37?
Ma'am, if we subtract 0.78 from 0.41, then it's 0.37.
Yes, 0.78 is wrong. So what is given to you here is CDF, right? It is cumulative distribution function. So this is, what 0.78 is, probability that x is less than equal to, when you find f of 2, how is f of 2 defined? F of 2 is defined as probability of x less than equal to 2, right?
Yes, ma'am.
And this would be probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Everything will get added up.
Yeah, got it, ma'am. Yes, fine.
But here, sorry, here we are talking about 1, right? Fx of 1 we are talking about. Yeah. So it is just 0.37. So you need to look at this difference. What is the difference? This was 0.78. If you subtract 0.78 from 0.41, you will get the probability. This difference is nothing but probability that x equal 1. Yeah. So that is 0.37. Now, similarly, what is the probability that x equal to?
Ma'am, 0.13.
0.13. So it is 0.91 minus 0.78. Right? And this is 0.13. And what is the probability that x equal 3?
0.09.
0.09. This is clear?
Yes, ma'am.
All right. Now, what the question was asking? What is the find the probability that there are 3 defective items in the shipment of 10 items. So probability that x equal 3, and we found it to be 0.09. Is this clear?
Ma'am, ma'am, the first probability you take P of x equals to 0.41. So that is understandable, but 0.78, why can you, ma'am, repeat it again?
Why probability x equal 1 is 0.78 minus 0.41, right? So
Yes, ma'am.
see this graph, that what you're looking here, this is the CDF graph, right? So when we are saying, when you look at 1 and you see that at 1 it is taking 0.78, okay, but you see, right, it is saying probability, f of 1, this is f of, if you put x as 1, it is probability x less than equal to 1. This is how CDF is defined, correct? And what is probability x equals 0? It is 0.41
Yes, ma'am.
plus probability of x equal 1. And what is f of 1? F of 1 is 0.78, right? So to find the probability that x equal 1, you need to subtract 0.41 from 0.78.
Yes,
Subtracting
ma'am.
this is nothing but what is the jump between these two values, right?
Right.
So this
Uh,
is exactly 0.37.
to be clear, ma'am, for if I find the f of 2, so f of 2, p of x is less than or equal to 2. So for that, p of x equals to 0, x equals to 1, x, then x equals to 2.
Okay, so now you tell me. So now I find capital F of 2, okay? Capital F, always remember, capital F is the notation for CDF, okay? Now
Okay,
F of 2 is what? Probability that x is less than equal to 2.
yes, ma'am.
So, and we see that x is taking the value 0, 1, 2, 3 from this CDF function or this graph. This is what we saw.
Mm,
So probability that x will take the value less than equal to 2, this is same as finding the probability that x equals 0 plus probability x equal 1 plus probability x equal to 2.
yes, ma'am.
Now, what is F2 given? F2 is 0.91.
0.9. Yes,
0.91. What is probability x equals 0?
0.41.
Or what you can write it as, now probability x equals 0 plus probability x equal 1. This you can write it as f of 1
Yes, ma'am.
plus probability x equal to.
2.
Now what is f of 1?
0.37
0.37. How? I'm
means
asking f
you
of 1.
0.41.
0.41. No. What is f of 1?
Ma'am, 0.78.
0.78. Look over here. This is
yes,
how
yes,
your
0.7.
CDF is defined, right? So my f of 1 is 0.78, right? and this is 0.91 plus probability x equal 2. So what can you write probability x equal to 2 now? This is 0.91 minus 0.78. And this is exactly this difference, right? This value
Yes.
is 0.91. This is 0.78. If you take the difference, between these two values, you will get, so this jump that you see here, this is nothing but probability x equal 2, right?
Right, ma'am.
Mhm. Now, okay, now let's do for x equal f of 3 also for your more clarity. So now let's say I want to find f of 3. Okay. So, I mean, f of 3 is already given. What I want to find is probability x equal to 3. Okay. What is f of 3?
Uh, Probability of x
Mhm.
is less than equal to 3.
Okay. Now, this you can write it as
Probability of x equals to 0,
hmm,
then probability of x equals to 1,
hmm,
then probability of x equals to 2,
hmm,
then probability of x equals to 3.
right? Now, the first three, see, we had to find probability x equal to 3. So I will leave that. And whatever is remaining, can you tell me what I can write this as? The
Uh,
circle thing.
f
In
of 2.
f of 2 plus probability x equal 3. Now, from here, from this definition of this CDF, tell me what is f of 3?
F of 3 is 1.
F of 3 is 1. What is f of 2?
It is 0.9.
0.91.
0.91 plus probability of x equal 3. So what is now probability of x equal 3? It is 1 minus 0.91. This is nothing but 0.9.
0.09.
And this is exactly this difference. So what, given the graph of a CDF, what you have to see is what is the jump at that particular value that your random variable takes. So if I had to find probability x equal to 3, see, look at 3 and see what is the jump at 3. What is the difference in these two values? Okay. If you have to find probability x equal to 2, look at the jump that you're getting at x equal to 2 value in the CDF. For 1, look at what is the jump that you're getting at 1. For 0, look at what is the jump that you got at 0. This jump was just 0.41. So that is why this probability x equals 0, we got it as 0.41, right? The difference was 0.41. This is clear now? So now you know how to, given a CDF, how do you go to a PMF? This is
Yes,
clear?
ma'am.
Okay. So we found what is probability x equal to 3. Now the next question that is given is what is the probability that at least 2 defective items are there in this shipment? So when we say at least, so what should you find here? Can you tell me?
Probability x greater than equal to 2.
Okay, this is fine. Now what is this equal to?
Probability of 2 plus probability x equals to 2, probability of x equals to 3.
Hmm. And you already have found that probability of x equal to 2 is 0.13 and probability x equal to 3 is 0.09, right? So this is nothing but 0.22.
2.
Yeah, so this is your answer. These are very simple. I mean, what you just have to, you should know the techniques. Like the first thing that you should learn for in case of random variable is given a problem statement, the first skill that you should know, can you identify the random variable? Okay. Once you identify the random variable, the next question is, can you tell what all the values your random variables are taking? Okay. Then what are their probability distribution? What I mean, when I say distribution, I mean, I'm talking about the probability mass function. And given a CDF, if you given a CDF, do you know how to convert it to PMF? And given a PMF, do you know how to convert it to CDF? So these are few things that you should know. Now, can you similarly try question number 2?
Yes, ma'am.
Just try work it out. Because there you have to find the CDF. And to find the CDF, how, like, what will you do? So what, I will just give you a hint over here, like what all you should take care of. Okay, you tell me what is your X?
Um,
I mean, what is your random
okay.
variable? Look at the question and tell me what is your random variable.
A random variable take 4 values, like number
Yeah.
of cards,
Number
number
of
of red
cards,
cards,
number of
number
red
of red
cards.
cards.
What is the range of X?
4, 0, 1, 2, and 3.
0, 1, 2, 3. Yeah.
Yes, ma'am.
Yeah, because 3 cards you're drawing, right? Drawn from the deck of 3 cards. So just try it out. You find the PMF. I mean, you find the probabilities for each of the values that your random variable take, and then you just have to add it up to find the CDF. I hope you can do it now. Okay. I'll move to EQ 10.3 question number 4. The question is, there are 1,000 mobile phone in a mobile wholesale shop. So you have 1,000 mobile phone, out of which 100 are defective. So defective of defective items is 100. A retailer buys 20 mobile phones from wholesale shop for a total price of 2 lakh rupees. So someone bought some 20 mobile phones for 2 lakh rupees. The retailer gets 2,500 rupees profit. Profit of 2,500 rupees if the mobile phone is not defective. If not defective. Okay. And 10,000 rupees loss if it is defective. Loss of 10,000 rupees if defective. These are for each phone, okay? Now, what is expected profit earned by the retailer? Question is, what is the expected profit? Okay. So the retailer had bought 20 mobile phones from that wholesale shop. And out of these 20, there's a chance that uh, each of the mobile can be defective. I mean, let's say X1 is profit on a mobile one, maybe. Hmm. Is there any other information given? Mhm. The information is not given that how many are defective, right?
Ma'am, in question it was given that 100 are defective.
This is out of, I mean, out of 1,000 it is given, no? Uh,
And number of defective pieces is equal to 100 by 1000 and non-defective is equal to 900 by 1000. So 1 by 10 into 2500 minus 9 by 10 into non-defective into profit plus defective into
Hold on, hold on. Yeah, wait, hold on. think I should get the answer, but I don't know. You have not studied binomial random variable yet, right?
I'm not started,
Yeah, someone was saying
but
something.
in the open session it was discussed.
Yeah, yeah. Can you repeat what were you saying? Sorry, I didn't listen to that time.
Ma'am, it is in week 11.
No, 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 not about
actually
yeah.
we can find out the probability of defective and non-defective by
That is fine.
so we are getting 9 by 10
Defective
non-defective.
would be 1 by 10 and probability of non-defective would be 9 by 10, correct?
So non-defective minus defective means 9 by 10 into 2500 minus 1 by 10 into 10,000. Then we get the
Uh,
profit.
wait,
So
tell
that
me,
profit
repeat again.
is
What did you say?
9 by
9,
10 into 2500
9 by 10 into 2500.
minus
Okay.
1 by 10 into 10,000.
1 by 10 into 10,000.
Yes. That loss is there, na ma'am? That one.
But what is this? What is
So
9
we
by
get
10?
the profit. 9 by 10 is the non-defective. Non-defective.
That is probability.
Yeah, yes, ma'am. Probability.
Yeah.
With the probability we can get that
No, no, no.
actually.
You can't do this. So, okay. What I was doing is what we can do is let's say I say I have X number of defective items. Or this is more like, okay, hypergeometry case, yeah. So, So you have a lot of 20 items and you have, let's say I have some to be defective, I can X to be defective, right? And remaining 20 minus X would be non-defective. Now, if I have X defective, defective, X mobile phone defective, so I will get a loss of, like for each mobile phone, I will get a loss of 1000 rupees. So I will have basically a profit of minus 10,000 X. And if I have, if X is defective, I have 20 minus X to be non-defective, right? So 20 minus X times 2500. So the profit that you're going to get is this function, which is, what is 25? This is, yeah. 25 to 50. 10,000. This will be 12500X. So I need to know the expected value of this, right? So this is nothing but 50,000 plus 2500 times expected value of X. Now, what is X? X is defined as number of defective um, 1000, out of which 100 was defective. We took a sample of 20 items. Is this with replacement or without replacement? It's mentioned. This is 2. What is the answer for this? 25,000. Yeah, it's correct. Yeah. See, I'll tell you what I have done here. Let me know if something you're not able to understand. I'll clear out few things. Okay. This. Right. See, we had 1,000 mobile phone in the wholesale, and out of 1,000, 100 were defective. So probability that any mobile phone will be defective is 100 by 1,000. So that is 1 by 100. Okay. Now we have some retailer who has bought only 20 mobile phones, right? So now in that 20 mobile phones, what I said is, let's say X are defective. Out of these 20, X are defective and 20 minus X is non-defective. Okay. That's fine. Now, if X mobile phone are defective, okay, and we know that if the mobile phone is defective, so per mobile phone, you are getting a loss of 10,000 rupees. So for one mobile phone, the loss is 10,000. So X mobile phone, you will get a loss of a loss of 10,000 X rupees. This is fine. And since we want the profit, we want the expected profit. So what we are saying is we
Ma'am,
will
you have written profit.
but I have written minus sign here. That is where I was going. So saying loss of rupees 10,000 X. This is equivalent of saying a profit of minus 10,000 X rupees. Is this okay? Loss of 10,000 X rupees is equivalent of saying a profit of minus 10,000 X rupees.
Yes, ma'am.
Now, if X mobile phones are defective, 20 minus X are non-defective. And we know that if the mobile phone is not defective, the retailer is getting a profit of 2,500 rupees. So for one mobile phone, the retailer is getting a profit of 2,500 rupees. So for 20 minus X mobile phone, the retailer will get a profit of 20 minus X times 2,500 rupees. Correct? So what will be the total profit? You can just add both these two. So this is what I have written here, 20 minus X. Did I write something wrong? Oh, I think I made a mistake here. Okay, wait. Oh, so profit is how much? Minus 10,000 X plus 25 to 50,000 minus 2,500 X. Oh no, this is correct only. Yeah, I think I wrote it correctly. And this is what I have written here. So this is my profit. This is okay.
Yes, ma'am.
Now this I have written it as 50,000. This can be simplified and you can write this as 50,000 minus 12500x Now, this can be written as what? This is 50,000 minus 12500 times expected value of x. But now I don't know what is expected value of x. So I need to find that, right? And what is x? My x was defined as number of defective items in number of defective items, right? This is out of 20. Um, so you had a total of 20 items, right? 20 mobile phones. And you can have zero defective mobile phone, one defective mobile phone, two defective mobile phone, so on till 20 defective mobile phone. And to find its expectation, you will have to calculate the probability for each of them separately. But we should not do that. I mean, finding the probability for 20 values that your random variable take is not easy, right? So I have used this binomial random variable concept, and from there I knew that this expectation is nothing but n times p. You will learn this when you go to week 11, so you don't have to worry about it. If someone has solved this question in some other way, maybe you can share that also. But finding the probability individually is not an easy task. So what we said is, since x is modeled as number of defective items, and your x can take all the values from all the way up to 0 to 20, such kind of random variable is modeled like binomial random variable. And in that case, I know that if any random variable x follows a binomial random variable with parameter n comma p, then I know expected value of x is np. So in our case, n was 20 and p is probability of defective atoms, and that was 100 by 1000, which is nothing but 2. And I just substituted here 2 and I got 25,000 as the answer.
Ma'am, initially you have like taken the expected value this random variable value to be x and 20 minus x. But in the when we are considering this the same as the binomial variable, it's considered as 0 and 1. So
Can you repeat what you said?
I'm saying that initially you consider the binomial variable to be that it is defective or non-defective, that is x
No,
and
no,
20.
no. That is not binomial. I mean,
No, that's definitely not a binomial, but you consider the this
what I said is,
variable.
I had 20 mobile phones, right? And out of 20, I said, assume that X mobile phones are defective, and remaining 20 minus X will be non-defective. This is what I said. And
Okay.
then for X mobile phones, if I am saying X mobile phones are defective, and I know that the loss for each defective mobile phone is 10,000 rupees, then loss for X mobile phone would be 10,000 times X, which is equivalent of saying that I get a profit of minus 10,000 X. And I knew that for every non-defective mobile phone, I had a profit of 2,500 rupees. So for this is in rupees, okay? And this is again 20 minus X time 2,500 rupees, right? So now the profit for the X defective mobile phone is minus 10,000 X. And the profit for this 20 minus X non-defective mobile phone is 20 minus X times 2500. This is my profit, right?
Yes,
And
ma'am.
now you have to find, you can write this combined profit as maybe Y. And now
Mm.
you have to find the expected value of profit.
Mm.
Hmm? So
Ma'am,
expect. Mm.
like here also I have a query. Like, you what you did is you said that it's expectation of Y itself, expectation of profit.
Hmm.
Thing is, from my understanding, this expectation is the long run average. Yeah.
Hmm. Yeah.
But if you are considering the all possible samplings, this 20 samplings from the a bunch of this 1,000 samples, 1,000 phones,
Hmm.
then there are a lot of like samples they are going to be that will have like zero defective products. So means how we are constructing like from profit to expected value of profit, but are not considering these values when we have a lot of samples that have
Yes.
like defective product.
See, that is not practically do I mean, that is practical, right? I mean, but if you have to solve a problem, we cannot go and, I mean, this information is not given to you, right? Like which mobile phone is defective, which is not defective, and you will have to go and check every mobile phone and say whether it is defective or not defective. But in theory, what you can do is you have to find the expected profit. So I found my profit. I found the profit to be this minus 10,000 X plus 20 minus X times 25. This is my profit. This is my profit function, right? And now we want to know that what is the expected profit? I mean, in in the long run here, we cannot say in theory, but what is the profit that you're expecting?
So this expectation is like mm,
So this, so expected value of the profit, right? Expected profit you have to find. This is what you have to find. And this is my profit function that I got. And this is, I mean, nothing but this function, 550,000 minus this. And I got at the end, this equation is what I have to solve. So to get
ma'am,
the final answer, I need to know expected value of X.
ma'am, can we still see this profit function that you have written as like but disregard means it's still a function. So
Hmm.
it is considering all the values that X can take, whether it's repeated or not. Yeah.
Hmm. Yeah, yeah. Hmm.
So in that sense, if we say that it's a function, that from the same idea that if we have this expected value of X, then we can still calculate expected value of G of X.
Hmm.
So if we see it from that perspective, then that's fine, like doing from this
Yeah.
expectation.
Hmm.
Hmm.
So this is nothing but G of X, right?
Yeah.
Hmm. And since right now you don't know what a binomial random variable looks like, so it's not easy to see why expected value of X is coming out to be 2. But I'm sure when you go to week 11 and look at what a binomial random variable is and come back to this question again, you will see that it will come out to be 2, expected value of X.
Hmm. Okay.
Hmm. Maybe there is other way to solve it, but definitely finding out each probabilities is not a way to do it. But maybe this problem maybe can be solved in some other way also. Okay.
Okay, ma'am.
Hmm. Any other question you have?
Ma'am, it's practice assignment week 9, question number 6, please.
Practice assignment 9, question number 6. So, question. Okay. Two friends, Ramesh and Suresh, wants to play book cricket game. The rules of game is your initial score is zero. Say nine. This is zero. You have maximum of five chances. Maximum chance equal five. Now you need to randomly open a book page. Um, the last digit of the right side page number will be added to your current score. All right. So if I have last digit, okay. My score. If you get zero, you are out and you won't have any more chance. Okay. Zero means out. Um, even though your chances are not done, the person who gets the highest score is the winner. Okay. The book Ramesh and Suresh are using to play cricket. Play book cricket contains 10 pages. So we have 10 pages. Numbered from 1 to 10. Okay. With the right side page containing even numbered pages. So here it's all even. Assume that there is an equal probability of opening for each page. Okay. So probability for each page is 1 by 10. The probability mass function probability dot x equal to x. And okay, this is for Ramesh and this is for Suresh. Okay. X equal xi. Suresh. Xi runs. Let's say. Okay. What is the probability that question is? What is the probability that Ramesh will be knocked out at the end of his chances? Ramesh is not. Okay, so Ramesh is not out, means what? That he didn't get out till the five chances.
Ma'am, one point to note is like it's having that odd number at the left side and even number of the right side.
Mm.
So the probability of getting something is like total number of options that I can get is only five, not 10. Because
Mm.
it's saying that I have to pick the score from the last digit on the right side of the book.
Yeah, you
So
have, I mean, ideally you have you only 2, 4, 6, 8, 10.
yeah,
I
so
guess.
based on that, the probability value should be like 1 by 5, no? of getting
I
a
mean, yeah, I mean, that I had written only from like 10 pages were given, so I just wrote 1 by 10. But yeah, I mean, for our question, you have only these 5 numbers which are useful to us. Remaining, we don't care. Okay, so not out in the maximum chance, it means he has played till the 5 chances and still it was not out.
Ma'am, can I tell you how I approached this question, but
Mm.
my answer is getting wrong here.
Okay, tell me.
Ma'am, what I did is like its probability of each page is like 5 1 by 5, yeah.
Hmm.
But I cannot get out in only in one case when I don't have like 10. That is, I have 2, 4, 6, 8.
Hmm. Yeah.
In that case, my favorable means probability that I'm not getting out at each step is 4 by 5.
Okay.
So what I did is like I am not getting Ramesh is not getting out, means he is not getting out at first, second, third, fourth, and fifth turn.
Hmm.
So that means that I can multiply because it's independent event. Because
Hmm.
every time I'm opening the book, it's not dependent on what my previous result was. So it's independent event. So probability of not getting out at first, second, third, and means all this satisfying is multiplication of this probabilities, that is 4 by 5.
Hmm.
That is 4 by 5 raised to the power 5. That's how I did it. Because my denominator is getting coming different in the given answer.
Answer is given as 4 to the power 5 by 5 to the power 13765. What is 1365? No, 525, 125, 625. What is 625 into 5? 12, 3125 it is. Yeah. Hmm. See, you could have multiplied all this probability when they were independent.
Yes, so, and they are independent because at each step I'm reopening the book. And
Hmm.
dependent what my result of previous opening was, what my previous result was. So I consider them to be independent based on this context.
Hmm.
Ma'am, I also
No,
did
but
in the same
no,
approach.
see, what happens is like in case see why it is not dependent independent is like in case you get an even number, I mean in case you get a 0, right? Then you won't be able to go and look at it again, right? So what outcome you get or what score you get in the next round depends on what score did you get in the previous round, right? There is a dependency between each round that you play.
The probability, if we consider the probability of winning now, means probability of getting the highest score or something in respect to the score, then
Mhm.
we want to consider that
No, no.
scenario.
I mean, we are not talking about the highest score. We are just talking about the game, how the game is going. It is going like let's say I am playing and you are playing with me. Okay. So I will get a chance. I will get the next chance depending on what what score I got in the current chance, right? If I get 0 now, if I get this page, if I open page 10, I'm out, right? So I can't go and redo it. So my next score is always depending on what my current score is, right?
But ma'am, in that case, but we are considering the probability of favorable thing, na? We can divide this sample space in like two parts. One is
Hmm.
favorable and one is not favorable. One in which I
Hmm.
get out and one in
Yeah,
which I
but
get out.
hmm. Hmm. Yeah, but I mean, sample space you cannot even how do you I mean divide your sample space?
Like ma'am, in the last question, just you did, no? Like
Hmm.
I'm getting
No,
either.
that is different. That is different there. Here you're talking about dividing the sample space into okay. Here, what is the question that we are trying to solve? The question we are trying to solve is finding the probability that Ramesh has played the game till the five chances, basically, right?
Yes, ma'am.
He has played the game. Now, if he has played the game for five chances, it means how should I look my sample space as? So it is more like not out. Uh, it is again not out. I mean, this is the event that you will get. Mm, I can maybe write it as in the first round, it is not out. Second, x2 is also 0. X3 is also 0. X4 is also 0. X5 is also 0. Okay. So, what the way we have defined it as, I mean, 0 is not out, okay? And if it was 1, we would have said it is out. So, x1 0, x2 0, x3 0, I mean, all from x1 to x5, I mean, for the 5 times, for the 5 turns, uh, Ramesh is not out. But it is, but we cannot say that even if I'm saying, even if I have defined it like that, I mean, this is what we have to find, and here everything is coming out to be 0. Still, I mean, if you think about this problem, you cannot say that, I mean, it's the same again, I'm repeating the same thing, but you cannot say that if I'm able to play right now, this depends on what my outcome in the previous turn was, right? Only on that basis, it is
Okay, ma'am. In
mm,
that, that case, can I go with the probability tree for this question?
probability 3
It's
means.
Yeah, it's dependent, and I means can I draw a probability tree to get us some answer in this question? Because at most I have like five outputs. At each step, I can have
No,
at maximum of five branches.
what is probability 3 you're telling?
It's like if I'm performing some that doing some experiment, I am expected to get like say two output. I'm tossing a coin. Yeah.
Hmm. Hmm.
So I'm saying that it's an unbiased coin. So what I said is I draw two branches. One when I get head, when I get a tail.
Hmm.
Both presenting both mentioning the probability of half half. Yeah.
Hmm.
Further, if I toss a coin again, then again the same node is divided into two further branches. One for head, one for tail. That is how with the probability of half half. If I say that my first and the second head should be what's the probability of getting first head and second head? That's 1/2 means the multiplication of the branches that I followed to get the particular result. So that's like half into half and so on.
Wait, you tell me again what your branches is.
I'm like
You have head, you have tail.
first draw a node.
Hmm.
Now I get two branches, one for the head, one for the tail.
Hmm.
Both on the branches, I'm writing the probability of getting head and tail. That's 1/2 and 1/2.
Okay.
Similarly, from the head and from the tail, I further have two branches. That is one for the head, one for the tail.
Okay.
Now, if I say that, what's the probability of getting two heads? That's the multiplication of 1/2 and 1/2. That is like saying the multiplication of the branches, probability of the branches that I get to the particular result.
Here it is, probability of two heads is 1/4.
Yeah.
And here it is coming out to be independent.
Mm. Ma'am, there is
Yeah,
a
but here,
ma'am also explained. Ma'am has included one of the others. Uh, uh, this what I say is,
hmm,
uh, ma'am has included one probability tree from for the dependent event, but I was not able to understand that exactly. Uh,
dependent, and it's in week 10.
no, ma'am, it's in the week 8, I presume. The topic was not included, but ma'am like included the same probability tree thing for this revision session for the quiz too. But
Okay.
I'm still struggling to understand the second part. Let me share you the slide. Just give me a minute,
Hmm.
please.
Okay.
So I was thinking that if we can draw a probability tree for the independent event,
Hmm.
so we will be able to like classify the particular event
See,
based on the
hmm,
dependency or independency.
here you were tossing two coin, right? So here, of course, what draw you get in the second time is not dependent on what you got in the previous turn,
Mm.
right? Because you will either get a head or you'll get a tail. I mean, whatever you got in the first turn, it is nowhere going to affect your outcome in the next term. But the problem that we have with us here, what you get in the next turn is dependent on what you got in the current term, right? Because that is the deciding factor whether you're going to play in the next term or not. Here we are just finding, I mean, here it is x1 equal to 0 to x5 equal to 0. And we are finding the probability, right? What is the probability that Ramesh has, like, is not out?
I have shared the same like link to the ma'am's
Okay, which
professor's.
one should I open?
Ma'am, it's first PNC.
Okay.
It's on the page number 76. Like I asked Misha in the last session, he said that I'll be forwarding this same probability tree thing to explain in the next session.
Okay. Sorting. Page number, what did you say? Page number?
76, ma'am.
The page is not loading. Hold on.
Ma'am, I have shared the PDF also if in the chat of the scene.
Mhm. Okay, maybe I can download this. This one, yeah. Page number 17.
76, ma'am.
76, okay. This one.
Yes, on this diagram.
Hmm. Then same one, yeah. Is the context for this diagram given?
No, ma'am, it's absent. That's why I was
Okay.
struggling to understand that.
Okay. So here, okay. Pick a ball from two bags. So you have, let's say bag one, you have bag two. Bag one has 4W and 3 black balls, and bag two has, okay, I think there are two bag two, is it? There should be a context for this question. Um,
And they,
because the same bag two cannot be at, cannot contain two different
ma'am,
sets.
from the discussion in the last session, the hunch
Mm.
that I get is it's
Mm.
like bag one is having four white balls and three blue balls, but bag two is having like three white balls and five black balls.
3
So,
and 5.
so if I three white balls and five black balls.
Okay.
So if I put one ball, pick one ball from the bag one and put that ball
Okay, okay, okay.
back.
Yeah, now it makes sense. Yeah. Okay. So bag one has 3 black and 4 white, right? Now probability that if you pick a ball from bag one, what is the probability that it is black in color? 3 by 7. This is fine.
Yes, ma'am.
What is the probability that is white in color? 4 by 7. Now I pick one ball from bag one and put it to bag two.
Mm.
Okay. Now this one ball can either be black or this can either be white. Right? If it is black ball, then in bag two, I will have 3 white and 6 black.
Yes,
And
ma'am.
if it is white in color, if the ball that you picked from bag one is white, then bag two will have 4 white. They become, 4 white. No, right? I mean, this also is not, I don't think, is it the context? Because
It's a
if,
hunch. I'm not 100% certain that
okay,
if
okay, okay.
it's
And, this is fine, this is fine. It was 3, right? I got confused from, yeah, okay. So bag 2 has originally 3 white and 5 black. Now, if you put 1 white, it becomes 4 white and black remains still 5 black, right? Now, from bag 2, if you uh, from bag two, what is the probability if you pick a ball now from this setting, if you have to pick a black ball, it will be 6 by 9. And if you had to pick a white ball, it is 3 by 9. From bag two, if white ball was transferred from bag one, then probability of a black ball from bag two is 5 by 9. And probability of a white ball from bag 2 is 4 by 9. Okay. Um, so what is the probability that uh, B1, what is the probability of B1 intersection B2? Now, what is B1? B1 is bag 1, is it?
It
It's
should be, I
saying
think that it's
so.
getting the first black ball and the second black ball.
Oh, right, right. Huh. It should be like that, yeah. Because I'm talking about this tree. Yeah, yeah. So first black and second also black. Um,
Is this context fine now that the hunch is about like,
this context is, yeah, I mean more like even this is a dependent case. You can see that, right?
yeah, ma'am.
Because what you get in the next what you get in back two will depend entirely on what ball was transferred from back one.
Mm. Yes, sir.
Yeah. So what we were talking about there is something similar. So that is why you cannot go and multiply all of it.
Yeah.
That will be wrong because all these will be dependent
So
on the
in that
previous
case,
term.
can I expect like this type of tree to like differentiate this cases when it's
Mhm.
based on the
No,
India?
I don't think even if you need to draw the tree, because I mean if you look at it, I mean this is just asking you what is the value that Ramesh is not out. So now not out means in each draw, so he has played 5 chances. In the first chance it is 0, second chance it is 0, third chance 0, fourth chance 0, fifth chance 0. And in all of these chances, the outcome of all these chances will depend on what outcome did he get on the previous chance. So that is why there is a dependency on his next draws. I mean, his next score.
Ma'am, from what I said, this that I can split this sample space of getting the result 2, 4, 6, 8, and 10. What I meant was that if I get a 10, then I'm out. If I
Hmm.
don't get a 10, that is I get 2, 4, 6, 8, then I am not out.
Hmm.
So, but I can only get one thing. These are mutually exclusive things. Either I'm going to get one of the 2, 4, 6, 8, or I'm
Hmm.
going to get 10. So they are mutually exclusive also.
Okay. Hmm.
So in that case, I was having like means having a thought of going from this probability perspective only, that I'm not out at first, second, third, fourth, and fifth.
Hmm. But you're getting this thing, right? That you cannot multiply all these probabilities because they're not independent. So now you'll have to look at all the different kind of cases and work with this. I think it's going to be complicated a little. Um, so do you want the complete solution also, or just
Ma'am,
do?
hint to how should I proceed in this direction, like using the probabilities. That will be great. Like then I can give a shot and ask again if I'm still.
Um, okay, I have you studied this part? Like in case it is not independent, how does this look like? I think you would not have studied.
But if
So there
it's
is conditional probabilities and all that will come into the picture, but it is multiple random variable. Uh, is there another way to do it?
conditional probability perspective, we can go ahead. Like
But
it's
this is
just
multiple random variable we're talking about. So that you have not studied yet, right? Um, okay. So
Ma'am, in
how?
the solution, cases are made. 5 cases are made.
So maybe you'll have to go with the permutation combination. Yeah, all that. Have to do. Okay, so there,
What
if I
what
look at
I
this,
was no, I was addressing to go with the probability thing. The reason is because I don't know, like if similar type of question comes in, then I am more inclined to go with the solution that is 4 by 5 raised to the power 5, but that's not showing correct.
yeah,
So I,
that will not be correct because they're not independent.
yeah, so I wanted to differentiate using this question that what went wrong with this thing. So
Mm.
that I can like differentiate that is it fine to go with the probability this probability thing?
Maybe maybe what you can take it as an exercise is like look for a problem where it is independent and see how these two problems are different.
Yeah.
I think once you get the problem like that, and then I think it will be easier for you to differentiate. And then you can come back and solve this problem in other ways. You can try that. Okay, Okay, maybe you can look at the solution also, how they have solved it. And then see.
Okay, ma'am.
No, from the solution I understand it was like I was
Mm.
trying to understand like
Yeah. So
if
if
I
you,
approaches with the probability thing because in the exam we don't know like it we might make error or like in the application thing. So I don't want that to happen in the exam. So I
yeah.
want to like differentiate what went wrong and what means to avoid this kind of errors.
Yeah, so yeah, that's what you maybe take it as an exercise and look for some problem where they are independent and see how they are different. And why a 4 by 5 to the power 5 doesn't work here. Okay, I think it's already 8. Um, is there any other doubt apart from this question?
Mhm. I will try to like go through
Mm.
it, but could you
Mm.
like arrange a few examples if I like still have trouble finding it? Could you like arrange one or two similar examples to differentiate this, where this probability thing that means this independent thing and
Okay,
dependent thing for the probability, so that I can differentiate it more better for the next session.
okay. So maybe I'll just note it down. And yeah, okay. We'll also work on that. All right. Yeah. Anything else?
No, ma'am.
Okay. I will stop sharing. Yeah. Okay, if there is no further doubts, maybe we can close for today. Meet in the next session.
Okay, ma'am.
Yeah. Okay. All right. Good night. Bye.